So we saw some problems from Math 4 according to the list that I have collected. Okay, 4117, I think you asked me.
Yes.
And then we solved that. So it is in the previous video.
Yes.
And the other problem that I see is 4123. But 4123, if I understand it correctly, you're supposed to use your calculator to draw the graph. Am I right?
4123.
4123. No, yeah, probably you need
to take it off. No, it's just to write, draw the graph. Sketch.
Okay, but of course I will not give this in my exam, but you need to know it for the national exam. But is it using calculator
This
or?
is sketch the graph on your own.
Yeah.
Then sketch it with your calculator and.
Okay, so let us do one of them in our own. For example, part B. So this is question 4, 1, 2, 3, part B, and the page is 120. So the function is f of x equals to x to the power of 4 minus 2x squared. And then the interval given is minus 2 less than or equal to x less than or equal to 2. Okay, we want to draw the graph of that one. Okay, so the first thing that we need to do is to actually differentiate it. So f prime of x is equal to 4x cubed minus 4x. Then I put my derivative equal to 0 and I solve it. So it becomes 4x cubed minus 4x equals to 0. And then what I factor 4x out and x squared minus 1 is left. I put it equal to 0, then I get 3 roots, yes? One root is 0, one root is negative 1, and one root is positive 1. Then I need to set up this sign table. It consists of 3 rows. So the first row is x, the second one is the derivative, the third one is the function itself. But here, because the interval x is going from minus 2 to 2, I don't need to go from minus infinity to infinity. I put minus 2 up to 2. And then I start arranging these numbers in order. So I put minus 1, then I put 0, then I put 1. Let me make distance. So then 1. Of course, the derivative is 0 here, the derivative is 0 here, the derivative is 0 here. I need to know the signs. Of course, you need to go and find a random number between minus 2 and minus 1 and put it here to see how it works. So if you do that, for example, I put minus, I don't know, 1.5. When I put it here, I will put it in the factorized form. It is easier. So if this one becomes negative, but this one to power 2 becomes bigger than 1, so it becomes positive. So when I multiply them, it becomes positive. So I realize that I have a positive sign here, yes? And then you can do the same thing for between minus 0 and 0, minus 1 and 0. You can just put minus a half, for example. This becomes negative, and then this becomes negative as well. So that's also positive. Am I right? So let me see. If I put minus 0.5 here, it becomes to the power of 2. It becomes positive 0.25. It becomes negative. That's also negative, so it becomes positive. I think I made a mistake in the previous one, yes? The previous one is negative. Let me double check. If I put a minus 1/2 here, so this becomes, yes, that is negative. That was my impression. So this becomes positive. Yes? And then what happens here, if I put something between 0 and 1, it becomes negative. And if I put something bigger than 1, then it becomes positive. Yes? Okay, this means that the function here is decreasing. Yes. The function here is decreasing. The function here is increasing. Again, here decreasing. Here increasing. But I need to know these numbers as well. So yes, I put -2 in the original function. So this becomes 16 minus what? 8. So that is 8. So this becomes 8. And of course, if I put 2, that also becomes 8, because this function has even powers involved, so it doesn't matter. If I put 0, this is clearly 0. If I put 1, the answer becomes -1. Definitely, if I put -1, the answer also becomes -1. Okay, and then I have to use this information here to sketch my graph. Okay, so let me set up a coordinate system. I don't need that much positive x values, but I want to have a higher y-axis. Yes, so let me make this one, for example, the x-axis. So the lowest one is -1, so I don't need to go below that much, but let me go higher. Okay, so the points that I am interested in is -2 and 8. So where is -2 and 8? So this is -2, 1, 2, 3, 4, 5, 6, 7, 8. Here is my 8. And -2 and 8 is here. And then I have -1 and 1, which is here. And then I have 0 and 0, which is here. And then I have 1 and -1, 1 and -1, which is here. And then I have 2 and 8, which is going back again here. Do you agree with me or not?
The -1 is -1.
What? Pardon?
The x equal -1 is fx equal -1.
Okay. Yes, you are right. So I have to clean that one. So this is if x is -1, y is also -1. Okay, but what type of points are these points? So this point, if you see, it's a minimum. This point is a maximum, and this point is a minimum. Okay, so this -1 and this is a minimum type. This is also a minimum type, but 0 and 0 is a maximum type. Okay, so I don't know if I can draw it good enough, but let me try to do my best. So it comes here, goes to this minimum, and then goes back here to this maximum, and then minimum. Yes. And then comes back here, and then of course it should go back here somewhere. In this case, of course, this is possible to understand these numbers exactly. So sometimes it is possible. For example, here in this case, I can put x to the power of 4 minus 2x squared to 0. Then you see that if I factor x squared out, then I get x squared minus 2 equals to 0. Then I get x equals to 0, x equals to minus the square root of 2, and x equals to square root of 2. So if you want to be really precise, this number is minus the square root of 2, and this number is the square root of 2. Okay, something like that. Is that understandable? Yeah? Yeah, this is good practice sometimes to know about that. Okay, and the next question they have asked is also the same thing, but okay, so let me skip, because question 4124 also asks you about sketching the graph on that interval, and then we want to determine the maximum and minimum value of the function in this interval. So if you don't mind, let me just skip the graphing part, but let me solve that second part. Okay, so we go to the next page. So this is problem 4123, and that's 1, 2, 4, and that is page 120. if that is the same pages, page 120. And I just want to calculate the maximum and minimum values. I just ignore the drawing. But you need to know, for the national exam, you really need to know how to draw the graph of a function, sketching the graph by hand. So f of x is x to the power of 3 minus 3x squared. Gustav, can you also please check whenever I find something the answer is right?
Yes, of course.
Thank you. So, do you remember the recipe? Here, of course, when I say what is the maximum and what is the minimum, I mean the absolute maximum and the absolute minimum. This is very important for the exam. Whenever an interval is given, remember this new recipe. Do you remember what was the recipe? If a function is continuous and given, an interval is also given, and you want to find the maximum value and the minimum value, the first step is, as before, to differentiate. What happens here? It becomes 3x squared minus 6x minus 9. Then I put the derivative equal to 0. This gives me 3x squared minus 6x minus 9 equals to 0. Because every number is divisible by 3, I make life easier if I divide everything by 3 first. And then you use PQ or ABC formula, or even factorization in that case. Factorization is easier. I put those two x's here and there. I ask myself, I need two numbers whose sum is minus 2 and the product is minus 3. What are those numbers? One of them is minus 3, the other one is plus 1. I put it equal to 0, and then I get two answers. One answer is minus 1, and the other answer is 3. Are these both acceptable? No. The big one is not acceptable. Why? Because this is outside this interval. So we will say that only minus 1 is acceptable. Okay, this is not in the interval. Okay, and then what we do, we actually need to calculate the value of the function at this acceptable point here. We also need to calculate the value function at the end points. Remember this. So the indication is that the interval is given to you in the question. So what you need to calculate, you need to calculate f of minus 1, which I got it from putting the derivative equal to 0. I also need to calculate f of minus 2. I also need to calculate f of 1. And then choosing the highest one is actually simple, yes? F of minus 1 becomes minus 1 minus 3 plus 9, which is 5. And then the f of minus 2 is minus 8 minus 12 plus 18, which is how much? Minus 2. And then f of 1 is 1 minus 3 minus 9, which is minus 11. Am I right? Okay, so then immediately you realize what is the maximum of f? The maximum of f is 5. Where it occurs at this internal point minus 1. But what is the minimum of f? The minimum of f is minus 11. Is that right, Gustav?
Yes.
Thank you. Okay, so remember this. Whenever you get a function and also an interval, this is the recipe that you have to follow in order to find the maximum and minimum value of the function. Okay. And then the next question people have asked is question 4133. So 4133. So the question is asking you the graph of a function y equals to f of x is given. Yes, so this red part is the graph of the function f of x. Part A, we want to determine the absolute value of part A. We want to know what is the absolute value of f of 3. Okay, I think it's very simple. What is this? You need to calculate f of 3 first. Okay, so if you want to calculate it, so you put an absolute value sign. Okay, can you tell me what is f of 3? You refer to this picture. This is 1, this is 2, and this is 3. So what is f of 3? Minus 1. F of 3 is minus 1. So just you put minus 1 in the absolute value sign, and then absolute value of minus 1 is simply 1. So that's the answer. But they have asked you to sketch the graph of the function, part B. We are supposed to sketch the graph of the function y equals to absolute value of f of x. Yes, I want to sketch this one. Do you remember what is the rule for doing that? We discussed a little bit about it. Of course, if you have forgotten, it doesn't matter. So you need to know what to do. So you shouldn't forget about the definition of the absolute value. So what is the meaning of the absolute value of f of x? It becomes f of x itself if what is inside the absolute value is non-negative. Yes, do you remember the definition of absolute value? But when f of x is negative, do you remember what is the absolute value? Minus f of x. So what is the interpretation? It means that if the graph of the function f of x is above the x-axis, when you say f of x is non-negative, it means the graph of the function is above the x-axis. Then you don't do anything. You just put f of x itself. But if f of x is negative, meaning that the graph of the function f is below the x-axis, you need to multiply the values of the function by a negative sign. So what is the effect of doing that when I multiply y value by a negative sign? It will be flipped about the x-axis, like that's a mirror image. So this means that, so if you don't, let me change my color here. For example, I choose this one. So you see this part, the graph of f is above the x-axis. So I shouldn't change this part at all. So let me just take my pen and draw something on it. Yeah, so that is this part. This part will not be affected. Okay? But then this part that goes below the x-axis, I have to flip it in a way that as if the x-axis is a mirror. Yes, so I should do it like this. For example, I don't know. It's not a real line, yes. So this is a little bit crazy. I mean, you have to do it something like this. I don't know. But the idea is that one. So you are supposed to sketch. You don't need to draw that. So this purple one is the graph of the function absolute value of x. Yes, is that clear? Okay, so we can take this one and put it. Oops, no, let us not change it. Okay, any questions here? Okay, so the next question they have asked is mentioned. So this is the question we solved in the previous video, so I skipped that one, 41, 42, and then we go to 42, 25. 42, 42, 25. So here the problem is asking you, so let me x plus 1. So we are supposed to give an example of a function which has two asymptotes, one vertical one with this equation and another one horizontal, oblique one with this equation. So what should we do? So when this x equals to minus 1 is supposed to be a vertical asymptote, so we have a candidate. So it means that we need to think about a function with a fraction so that minus 1 is a root of the denominator. That's a good idea to start with. And then this you want to have it as an oblique asymptote. So if you have this kind of function, so let me write this idea. So if you have a function f of x with like this, so let me write it like this. F of x is equal to mx or in your book it is written kx plus m, and then you have another function g of x added, so that the limit of g of x when x goes to infinity plus or minus is 0, then y equals to kx plus m is an oblique asymptote of f. Okay, so let us consider this. Why is that? Because of the definition. Yes, do you remember what was the definition of an asymptote? The asymptote is that if the limit of the distance between my function, so in the book they haven't mentioned absolute values, so let me follow the book. If I have this limit, that was the definition of an oblique asymptote. If we have this limit equal to 0, then we can say that this line is an oblique asymptote of this function. But now look, if my function is of this form, when I put it in this formula, this one and that one and this one and that one are gone, and g of x is left. And now I am telling you, assume that the limit of g of x is 0, so this means that this limit is 0. So that's the reason. Let me clean this, we don't need that anymore. Okay, but can you now understand what we can do? Let me write it for you then. So we write f of x equals to, so I put x plus 1 here, yes, because I want to give the role of oblique asymptote to x plus 1, so I put x plus 1 here. My duty is twofolded, yes? Once, I need to write a function here so that this limit becomes 0. Moreover, I want to write it in a way that x equals to minus 1 is a root of the denominator of something. I think the simplest possible scenario is to write plus what? You remember? 1 over x plus 1, yes? Yes? So that's an example of a function of this type. So let me just ask the other way around. Assume that I give you this function and I ask you to find asymptotes for this function. Okay, so you immediately can see that x equals to minus 1 is a vertical asymptote. Why? Because the limit of my function when x goes to minus 1, for example, from the right, it becomes 0, and then this becomes minus plus infinity. So the answer becomes plus infinity. So that's right. And then if I ask you what is the limit of f of x minus x plus 1 when x goes to infinity, you get this is the limit of 1 over x plus 1, x goes to infinity, but you know that this limit becomes 0. So we were able to engineer a function with that property. I don't know what is the given answer in the book, what they have mentioned.
The answer is y equals to 1 over x plus 1 plus x plus 1.
That's the same thing?
Yep.
Okay, so that's the simplest possible example comes to mind. Yes, whenever you want to make a line to be an oblique asymptote of a function, try to write your function in this form so that this part has limit 0 when x goes to infinity. But here we also want to have x equals to minus 1 as a root of some denominator, so that when x goes to that number, the whole function blows up. So if you put these things next to each other, this is one of those examples. Yes, is that clear? Okay. Okay, so let us see what is the question. So a function is given to you, a function f of x is equal to x to the power of 3 plus 4x and then divided by x squared. We want to find the vertical asymptote. Okay, so do you remember what was the recipe for that? To find the vertical asymptote, so let me write it here. I need to ask myself, what is that number so that when x goes to that number, the function goes to infinity, or either plus infinity or negative infinity. So do you remember the vertical asymptotes are somehow simple, but you need to confirm that. So what is the candidate? What is the good candidate for this? I put x equals to 0, x, the denominator 0, and I get x equals to 0. So far, we don't know yet this is the really vertical asymptote. So x equals to 0 is a candidate for a vertical asymptote. But how can I confirm this is really the case? How? I need to calculate the limit of my function when x goes to 0. Yes? Either from right or from left, but one of them is enough to be infinity. Yeah, so let me, for example, here send it to plus 0 from the right side. So we need to calculate this limit. So writing this is part of the solution. So x to the power of 3 plus 4x divided by x squared. I need to calculate this limit. But what type of limit is this? This is 0 over 0. When I put 0 here, it becomes 0. When I put 0 here, it becomes 0. So what can I do? I have to remove x. So I factor an x out in the numerator, so it becomes x squared plus 4. And I write x in the denominator, x squared in the denominator, and then I realize that one of these x's are gone. So what is left for me is x squared plus 4, and in the denominator, what is left is x. Okay, what the limit is now? Now, if I replace 0 again, this time the numerator becomes 4, but the denominator becomes negligible. So if I divide 4 by a negligible number, the answer becomes what? Plus infinity. So then you would say that x equals to 0 is indeed a vertical asymptote. Yes? Okay. And now we are supposed to find the oblique asymptote. Okay, and I don't know is it in the formula sheet or not. Have you checked that? There is a formula for finding, because so if that's not the case, you have to remember it. So what is part B? So let me remind you, if you want to find y equals to kx plus m, if you want to find this, there was a formula for k. It was the limit of your function, whatever it is, divided by x. When x goes to plus or minus infinity, you have to check them both. And then after you found, so this is part 1, you have to calculate k, and then calculating m is limit of your function minus k that you found earlier times x. So you check that are these formulas in the formula sheet or not. The formula sheet is already on the under the tab of class work on Google Classroom.
I don't think they are.
Okay, so if they are not, I don't know, you have to remember them. So this is part 2. So this is the lesson. Okay, now I use this idea to find the oblique asymptote here. So the function here is this one. I have to find k value first. I take my function, which is this one, and then divide it by x and take the limit when x goes to plus or minus infinity. I have to consider both of them. The examples in your book, usually they give the same answer. So in principle, you have to consider them both, but one of them probably is enough. So k is equal to the limit x goes to plus or minus infinity. Your function is x to the power of 3 plus 4x, and then divided by x squared, and then divided by x. Okay? But this is very simple because when I divide these two, it becomes x to the power of 3 plus 4x, and then it becomes x cubed. Yes, x goes to plus or minus infinity. Okay, so do you remember we had this in matrix C? So we divide everything by x cubed. So the numerator becomes 1. It becomes 4 over x squared. And then the denominator becomes 1. Simply, I just divided everything by the highest power of x. And if I ask you what is this limit, so this is just 1, this is 1, but x is huge, so 4 over that number is 0, so this becomes 1. So this means that the k value is actually equal to 1. And it doesn't matter if x goes to plus infinity or negative infinity. In both cases, k is equal to 1. And then after you found k, you need to find m as well. So this, you write the limit, you write your function minus the k value that you found times x. So the function is what? X to the power of 3 plus 4x divided by x squared, and then you have minus x, and then you have to calculate the limit of this function when x goes to plus or minus infinity. Okay, and then if I take the common denominator, so the common denominator is x squared, so this becomes x cubed plus 4x minus x cubed, and x goes to plus or minus infinity. And then you see that this one and that one are gone. So what is left for me is limit of 4x over x squared, x goes to plus or minus infinity, which is very simple now because this becomes simply 4 over x, x goes to plus or minus infinity. What the answer is? 0. So this means that the m value is just 0. Okay, so let me write the answer here. So y equals to kx, which is just x, plus m, which is 0. So this is your oblique asymptote. Okay, this is one way, but yeah, I think this is probably here is the only way. Of course, you also learned the method of long division. Okay, let me just not distract you with this example. Okay, and then part C of the problem is asking you to determine all extreme points of this function. Okay, so if I want to solve part C as well, so this was my function, f of x is equal to x to the power of 3 plus 4x over x squared. Okay, so because you know that for finding an extreme point, I have to differentiate. And differentiation here, I would prefer not to use the quotient rule, yes? It is possible, of course, to use the quotient rule, but there is a simpler way. Do you remember? I told you this before. So this trick, whenever you can avoid the quotient rule, I myself prefer to avoid that. So I divide this in this form. Okay, now let me, just by the way, let me give you also another trick for the, so here it works, I think. So because then you write it x plus what? 4 over x. Do you agree? Yes or no? So I divided them. And then do you remember this limit is 0 and y equals to x is your oblique asymptote. So that's also acceptable. So instead of writing also many limits and things like that, if you just do it, because I told you that if you have kx plus m plus gx, and if gx goes to 0 when x goes to infinity, then it is guaranteed that what you see here is the oblique asymptote. So I would say that this is a simpler way. I don't know why I missed that one, but anyway, that one that I solved is the general case that this cannot be done. But if it can be done as if here, so in the exam for part B, you can write it like this, and then write it like this, and show that the limit of 4 over x goes to infinity is 0, which is indeed the case, and then claim that y equals to this is your oblique asymptote. In this case, it is working. Okay, anyway, But now I need, because I want to differentiate, I continue a little bit more and I write it as 4x to the power of minus 1. Okay, now I start differentiation. Okay, I did this because I wanted to avoid the quotient rule. If you like to work with quotient rule, you don't need to do this step. So the derivative of x is 1. The derivative of x to the power of minus 1 is minus 4x to the power of minus 2. Then I put it back in the normal form by writing positive powers. So this is my derivative. Then I have to put my derivative equal to 0. So this means that I have 1 minus 4 over x squared equals to 0. So this means that 4 over x squared is 1. So this means that x squared is 4. This means that x is minus 2 or x is 2. Okay, but they have mentioned extreme points. Okay? So you need to convince yourself that they are extreme points because they might be a terrace point. So if you want to convince yourself about that, what is a good way here? I myself here prefer to do the second derivative test, because if I want to do the first derivative test, I have to draw that sign table. Because the second derivative is also very easy to calculate in this case, I prefer to use the second derivative. Of course, I have to be a little bit lucky. The second derivative, if it is 0, then it means that I have to go back and use the first derivative test. So I take the second derivative here. So this becomes 0 plus 8x to the power of minus 3. So when I simplify that, f double prime of x is what? 8 over x to the power of 3. Now, if I calculate f double prime at minus 2 that I found here, it becomes what? It becomes negative 1, which is negative. Negativeness important. The value is not that important here. So f double prime of 2 becomes 1. This is positive. Whenever it is positive, that point corresponds to a minimum point. Whenever it is negative, that point corresponds to a maximum point. And if you are unfortunately unlucky and the second derivative also turns out to be 0, this test is silent. You have to go back and do the first derivative test. Okay, so what are the points? So I would write minus 2, and I put minus 2 in my function. So the answer becomes minus 2, minus 2, minus 4. This point is a local maximum, and the point 2, 4 is a local minimum. Yes? And if you want to sketch the graph, of a function which contains asymptotes, you have to do the asymptotes first. So this is the x-axis, for example, and I hope that the numbers are not that big. So here I have the y-axis. So the first thing that I do, I draw the asymptotes. So this is one asymptote itself. Yes, do you remember x equals to 0 was the vertical asymptote? So remember, this y-axis itself, x equals to 0, is a vertical asymptote, and y equals to x is the oblique asymptote. So I change my color. So for example, this is my oblique asymptote. Okay, something like that. So this is the oblique asymptote. And then I don't know, you find those numbers minus 2, and minus 4. So somewhere here. And this is your maximum point. So the function should look like this here. And then you have 2 and 4, which is somewhere here. So the function should look like this here. And then you have the asymptotes as well. So you need to show that you know the concept of the asymptote so that the branches are getting closer and closer. There is no space, but you need to continue. Okay? Any questions here? Okay, so that's it. The other question they're asking 43:12.
the function is minus 2x third 3 over 3 plus
33.
squared. Sorry?
Is the answer that I have written correct?
Yeah.
Okay, so that's correct.
Yeah.
Okay. Okay, so I don't know why they have put this exercise when we are talking about primitive functions. There are no relations here, yes? Okay. Another question they have asked is the next question. Okay, the next question is related to primitive functions. Okay, so let us solve that one as well. So 40, what? 3 and 13, the same page, which was page, what was that?
139.
139. Okay, so that's a better question. So it has more chances to appear in the exam rather than that one. So this is x minus 3. We want to find f of x so that its second derivative is this, but f prime of 0 is 2 and f of 1 is 5 over 6. Okay, so because this is a second derivative, I want to go by one primitive function, I go to f prime, but another primitive function, I will go to f. Okay, so let us just do that. So if you tell me that f double prime of x is equal to x minus 3, then what can I conclude? I can conclude that f prime of x is a primitive function for what you see. What is a primitive function for x? It is famous, yes? 1 over 2x squared. What is a primitive function for 3? It is just 3x. But you remember that I have to put a constant c here. And then this information is provided for you to find c. So now they are telling you that f prime of 0 is supposed to be 2. What does it mean? It means that if I replace x in f prime with 0, the answer is supposed to be 2. So this guarantees that c that I didn't know before is 2. Okay? But now I need to know f. So I take another primitive function here. So what is a primitive function of f prime? So this becomes f. A primitive function for this one. What is that one? Can you do it in your head? 1 over 2x to the power of 2. 1 over 2 is just 1 over 2. X squared is 1/3 x cubed, yes? So then 1 over 2 times that 1/3, it becomes 1 over 6, x to the power of 3. And the next one is 3 over 2, x squared. And then I have cx. So let me write cx. And then, of course, a new constant. So let me call it constant. Let me call it d, okay? You cannot choose the same letter because we already chose C. Now I have to choose a letter. But of course, I know that C is minus 2. Sorry, C is 2. I can put it here. And then I also have an extra piece of information which I haven't used so far. It means that if I replace x with 1, the answer is supposed to be 5 over 6. So f of 1 is 5 over 6. So this means that I replace x with 1. So it is 1 over 6, 1 to the power of 3, minus 3 over 2, 1 to the power of 2. C times x, but c is 2, x is 1, and d is unknown. And this answer is supposed to be 5 over 6. And then I can calculate that. So this becomes just 1 over 6 minus 3 over 2 plus plus 2 plus d is equal to 5 over 6. And I move it. So let me calculate that. So if I take the common denominator here, 6, that is 1 minus 9 plus 12 plus d is equal to 5 over 6. And then finally, what is d? This number is how much? 4 over 6, so it's 1 over 6. These are simple calculations. But you have to write the final answer, remember. So you write the answer, the function f of x is this function, c is 2, d is this number. I plug them here. So the answer, hopefully, you can also check it, please. So this is this function if I haven't done something wrong. Yes? Is that right?
Yes.
Okay, good. So this is a better problem. The previous one I will not give it for this chapter test, of course. So the next problem they have asked 4327. 4327. Okay, so that's a better problem. So, but I have already discussed about how to. I think in my lessons I did that, but let me just do it here. So 4327, yes, and that is page 144. Okay, so we are supposed to calculate two integrals. So the first one is integral from 0 to pi over 2, and then you have sine x, cosine x, dx. Yes? How should I calculate this? This is part A. I hope that this combination is familiar to your eyes. If that is not, then the chances of solving that is more or less close to 0. So if sine x, cosine x is something familiar to your eyes, you go and search the formula sheet, then you will find this formula. Sine 2x is equal to what? 2 sine x cosine x. Okay? But of course, the combination that you need here doesn't have that 2. So it's a very minor thing. So what can I do? I can write this integral from 0 to pi over 2. But instead of sine x cosine x, what can I write? I can write 1 over 2 sine 2x. Agree? Dx. And then what happens, this 1 over 2 is a constant. I can take it out from integral, and it goes from 0 to pi over 2 sine 2x dx. But this is a famous one. You have it in the formula sheet. So if you have sine kx, its primitive function is what? Minus 1 over k cosine kx, which you get in formula sheet. So I will use it here, but k in this problem is 2. I already have a 1 over 2 here. So the answer becomes what? The answer becomes I have a 1 over 2 here, and then multiplied by minus 1 over 2, minus 1 over k, and then cosine kx, which is 2x. But I'm supposed to calculate this combination from 0 to pi over 2. So if I simplify this a little bit, it becomes minus 1 over 4 first, and then I have cosine 2x. X goes from 0 to pi over 2. Okay, and then what I have to do, I have to replace x with pi over 2, which is minus 1 over 4 cosine pi, because if I replace x with pi over 2, this 2 will cancel that 2. But do you remember what is cosine of pi? It's negative 1. So this becomes 1 over 4. And then I replace x with 0. It becomes minus 1 over 4 cosine of 0. But cosine of 0 is 1. So it becomes minus 1 over 4. Then I go back to horizontal line. I write what I got above minus what I got below. And then this is important because some people get it 0. They mess up the minus signs. But the answer is 1 over 4 plus 1 over 4, which is 2 over 4, which is 1 over 2. Okay, please check my answers so that I am writing the second part. Yes?
Correct.
Is it?
Yep.
Okay. So you have questions?
We actually don't get sine kx in the formula sheet. We only get sine x. And
No.
it's antiderivative.
Is that right? That's your problem. I love torturing you. You need to respect the memory, a little bit at least. But how is that possible? Because for the derivative, are you sure about that? We have two tables, yes?
Yes. The first one, it doesn't either say It also says sine x equals cosine x, or the derivative of the sine x equals.
Now for the derivative I agree, because that is part of the lesson of the chain rule. But I didn't know that for the integrals you don't. Okay, but anyway, this is, you have to live with it, okay? Okay, so part B. What is this part B? This is integral from 0 to pi over 4 this time. And then what do you have? Aku, what do you do in Japan? Do you memorize things? Formulas or no? The formulas are available. Yes? I'm talking to you, yeah?
Yeah. We don't memorize the cosine x minus sine.
No, I mean, in the exam, you have a formula sheet next to you.
Yeah, we memorize. Like.
Oh, so that's a global problem now. From west to east, yes. Okay, good. Might be that's better, I don't know.
Maybe not, maybe
Yeah. Okay, so let us solve that problem. What's your opinion about that? I'm completely sure when I was teaching, I solved something very similar to this problem. So here, you have to expand. There's no other way, for example, to do it here. So what I do, I will first use my trigonometric knowledge. So this is 0 to pi over 4, and then I raise it to power 2, the first one squared, 2 times the first one times the second one, yes, and then the second one squared. Okay, then what can I do? I make life simpler if I recognize that this is a famous combination, yes?
Yes.
So what is that?
1.
1. And there is also another famous combination now that you just saw it, yes? That's it. So I use my formulas here. So this becomes equal to integral from 0 to pi over 4. I write 1, and then I write minus sine 2x. Okay? But you know that if you want to find this integral, you need to ask yourself about the primitive function for this one. Of course, this is easy. Primitive function for 1 is simply x. I just told you a primitive function for sine kx. So it becomes minus minus, which becomes positive 1 over 2, and then you have cosine 2x. And then, of course, you have to run this from 0 to pi over 4. Oops, I have to put a vertical line in front first, and then from 0 to pi over 4. So I don't know if I can fit it here. If I put pi over 4, the first one becomes pi over 4. The second one becomes what? 2 times pi over 4 is pi over 2. Cosine pi over 2 is 0, so that's good. So this only pi over 4 will survive. And then if I put 0, x becomes 0, but cosine of 0 is 1. So it becomes 1 over 2. And then if I go to horizontal line, I write the number above minus the number below. Can you check the answer of this one, please?
Yes, of course. Yep.
Okay, good. The next question they have asked 4329. 4329, where is that?
It's on the same page.
Okay, so here we are supposed to give, okay, so let me read it properly. So problem 4329 on page what is the page? 145.
Sorry, 4.
4.
Yeah.
144. Okay, so this is also an open question. Give an example of a function f so that the integral from minus 2 to 2f of x dx is negative, and the area of the region between the graph of the function x-axis and these lines are greater than 0. Okay? It's a good question because it wants to tell you that, of course, area and integral are very related together, but they are not exactly the same thing. So you want to make the integral negative but you want to make the area. By the way, this I don't exactly understand. What? Of course, the area should be greater than 0, shouldn't it? Okay, so okay, they should ask the question the other way around. Give a function so that this integral is negative. Even so, I don't know. Let us try to see what is the meaning of this question. Do you have any clue what to do? Do you see if my translation is correct? Yes, give as example of a function so that this integral is negative and the area of the region between the graph of the function and these vertical lines is bigger than 0. So of course the area is bigger than 0. Yes, I probably understand what they are trying to say.
I think so.
Yeah, but it is very strange because area is always positive.
Yeah.
You cannot say that the area is negative. Okay. So the point is that give a function so that this integral is, so you need to give a function so that the graph of the function is below the x-axis. Yes? The area, of course, becomes positive as you expect, but the integral becomes negative. So I don't
I
know.
think so, yeah.
So I mean, what is the simplest possible scenario? Can you imagine? So if I draw a graph here, so you have x-axis and then you have the y-axis here, for example, and then I want here is -2. For example, let me exaggerate a little bit. Here is -2 and here is 2. Okay? You want to have this integral negative. So it means that I can just draw this function below the x-axis. Yeah? So I would prefer to make it very simple. I don't know what they are going to do, but I can write this function, yes? Say x, y is equal to -1. If I ask you what is the area, but of course they don't mean this because it is clear that they have formulated the question wrong. So if I ask you what is this area, the area is positive, of course. But if you calculate the integral is negative. Yes? So if I calculate this integral for this function, f of x equals to -1, then what happens? This becomes what? Integral, it becomes, so the integral from -2 to 2, and instead of f of x I just simply put -1 dx. But what is a primitive function for -1 is -x, and I go from -2 to 2, so it becomes what? Oh, it becomes negative, it becomes 0. No, it becomes negative. So I must have, so this is very important, by the way, to go this like this. I put 2, I put -2, and then I go horizontally. So the answer is -4, which is negative. So this function, I don't know, what is the answer they have mentioned? I don't like this question because area is always positive. You cannot say that, okay, make the area positive. I think they want to do it like this. They want you to draw a graph, what I understand from this question. They want you to do a graph so that the negative part is bigger. For example, I can draw this line. I don't know, for example, y equals to 2x. So making it a little bit like this, so that when I go from -2 to 2, yes, this part is negative, this part is positive. When I add them, so exactly the other way around, yes. No, I don't know what they mean. What they have written?
So the answer is f of x equals to x squared minus 16. So they wanted you to give a function such that the area or the integral was less than 0.
Okay, so yeah, they have, yeah, so that mine is also working. I don't know why they have made that example. Yes, yeah, that's then that is true. Okay, so let us just clean that. I mean, this is simpler. Of course, what they have mentioned, you said x squared minus
Minus 16.
minus 16.
Yeah.
Okay, I don't know why. Of course, that's also correct, but this example is simpler, isn't it?
Yeah.
Minus 1. Anyway, the next question that is in my list here is 4331. Okay, so that's understandably a good question, but we discussed about this. I don't know if you remember it or not, but let me just do it. 4331. Page 145, yes. I'm sure that we solved that problem not in this topic, that this is an integral. I was talking about primitive functions about that. So A, we want to calculate the integral. This is a good question. Pi over 6 up to pi over 3 sine x cosine x. And they intentionally have written it sine over cosine because they could easily write tangent, yes? Okay, why is that? Do you remember I told you that there is a rule for differentiation, ln of u prime. What is that? It is u prime over u. So it means primitive function of u prime over u is simply ln of u. So if you don't remember this, there is no way for you to solve that problem. And we had this in our lesson. Okay, so here, there is also a little bit of problem here, because this is good, but the derivative of cosine is not sine, is negative sine, which is not exactly this case. So what we do here, we need to fine-tune it a little bit, yes? So let me write it like this. If I ask you what is a primitive function for sine x, cosine x, you can imagine this as primitive function for negative and then again negative. I'm sorry, cosine x. Yes, I just multiplied two negative signs. Of course, the net effect is nothing because this cancels out. But why I did that? First of all, this minus sign, I can pull it out, so it becomes negative primitive function of sine minus sine x cosine x. But the answer to this part, according to this rule, is very simple. Because if you in your head take this u, then this is exactly u prime. And this combination u prime over u is exactly what I have written here. So primitive of u prime over u is nothing except ln of u, but you also have a negative sign. So this becomes negative ln of u, but what is your u? Your u is cosine x. This is your primitive function. Now I go back to my integral, yes? This becomes equal to my primitive function that I determined here, but I have to calculate it from pi over 6 to pi over 3. And then I go like this, I replace x with pi over 3. Let me continue. Cosine of pi over 3, I have it in my memory, is 1/2. So this becomes ln of 1/2. But are you comfortable here if I write positive ln of 2? So remember, ln of 1 over x is equal to minus ln of x. Yes? And you should also remember that ln of 1 is 0, ln of e is 1. These are also important. So that's ln of 2. And then I go to the next part. I replace x with pi over 6. It becomes minus ln of cosine pi over 6. But cosine pi over 6 is square root of 3 over 2. and then I go back to the horizontal line, I write the number above minus the number below. So this becomes ln of 2 plus ln of square root of 3 over 2. But there is a better way to write it. I can write 1 ln, and I can multiply these two numbers. And then this 2 and that 2 are cancelled. So the answer is ln of the square root of 3. Might be in the faucet they have written this answer, or might be they have written 1 over 2 ln of 3. Yes?
They wrote both.
Both. Okay. They can write one more. ln of 3 over 2. Yes? Yeah, all of them are correct.
Yeah.
Anyway, it doesn't matter. Okay, so that was a good question. The second question I also remember I was teaching. When I was teaching, I did it for you. But not for integrals, for primitive functions. But that's the same story. So part B of this question is asking you to calculate this integral. So from 0 to pi over 2, 1 minus sine squared x dx. So this is one of, first of all, 1 minus sine squared has a better name. What is that? What can I write? Cosine 2. So this becomes cosine to the power of 2x. This is one of those hard problems. If you don't know the rule, might be you really be in trouble. It is not clear that you need to go and look for the double angle formulas, okay? So if I ask you what is cosine of 2x, there are three formulas. Let me use one of them. So it becomes 2 cosine to the power of 2x minus 1. Then I move 1 to the other side. It becomes 1 plus cosine 2x is equal to 2 cosine x squared. But you see what I have as my integrand is just cosine x squared. So this motivates me to divide everything by 2. So this means that cosine to the power of 2x is 1 over 2 plus 1 over 2 cosine 2x. So this is the trick. If you don't remember this trick, I think the chances to solve the problem is very close to 0. Okay, and then you go back and replace this with this new formula. So what happens? This becomes equal to integral from 0 to pi over 2, yes, and then 1 over 2 plus 1 over 2 cosine 2x dx. Okay, a primitive function for 1 over 2 is simply 1 over 2x, and a primitive function of cosine 2x is 1 over 2. There is another 1 over 2, it becomes 1 over 4 sine 2x. And then I have to calculate it from 0 to pi over 2. So then I will do like this. So I will have it. I put pi over 2 there. It becomes pi over 4 plus 1 over 4 sine pi. But sine pi is 0. So this answer becomes simply this. And when I put 0, both of them actually become 0. And then I go back to horizontal line. I write pi over 4 minus 0. So the answer should be pi over 4 if I haven't done something wrong. Yes. Okay, one more question here on page 164, question 10, part C.
64. Is that blue pages?
Yes. Let us see. 164. Question number 10,
Okay.
part C. You are supposed to calculate the area, yes? Okay. If you just, and that's the graph. So if I understand, we just need to calculate the area. So it shouldn't be hard. But the point is that you see that this area is below the x-axis. So if I want to calculate the area, I write area is equal to not the integral, negative of the integral. From where to where? This line up to this line. So this is what? Minus 1, minus 2, minus 3. So if it goes from minus 3 up to minus 1, and your function is 1 over x, and then you have dx. Okay, So might be I know, because you know that the formula in the book is only working for positive x. But if you remember when I was teaching you, I told you that the correct version is to write ln of absolute value of x. Okay, so this is one of those exceptions. You cannot bring it up and write it x to the power of minus 1. Yes, do you remember the formula x to power a is 1 over a plus 1, x to power a plus 1 only works if a is not equal to minus 1. For this one, that is just very simple. It's just ln of not x, but absolute value of x. This is the correct way. I don't know why the book has written it only for positive values. Okay, then what happens for the negative values? Of course, you can use symmetry and say that, okay, I go to the positive part, but that's a problem. Okay, so I would go it from minus 3 to minus 1. So then what I do, I just write minus ln of absolute value minus 1, and then I replace x with minus 3, and then try to calculate them. So it becomes minus ln, absolute value of minus 1 is 1, but we just review. What is ln of 1? Is 0, so this is 0. And then this becomes minus ln of absolute value of 3, and the ln of absolute value of 3 is just minus ln of absolute, ln of 3. And then I go to horizontal line, the number above minus the number below, and these two minus signs are cancelled, so the answer becomes ln of 3 area units.
Yeah.
Is that right?
Yeah.
Okay, so the questions in my list at least is finished. But if you have, what time is it? Yeah, if you have questions, you can still ask.
Only mention one, or they have the same answer when x approaches negative and positive infinity.
Hmm?
In the exam, will you consider like a different answer for each?
No, I haven't designed the exam yet. Yes. I don't know, but yeah. In principle, you should check both of them. I don't think it is easy to design a question at the high school level that if you send x to positive infinity, it gives you an answer, and send you to negative infinity, because usually this happens if you have square roots involved, and those limits are beyond the scope of high school. So in principle, but you need to pretend that you know the topic and write plus and minus, even the answer is the same. Yes. Any other questions? Okay, so what you are asking is question 4217.
Yes.
4217, page, what was that? 128. Okay, so y equals to a, where a is a constant, is the asymptote to this curve, where x is positive. Determine this one. Okay, it should be 0, isn't it? Because when you say y equals to a is an asymptote, it means it is a horizontal asymptote. Do you agree?
Yes.
Because y equals to a is a horizontal line. So it is a horizontal asymptote. What is the meaning of the horizontal asymptote? It means that when I take the limit of my function, f of x, and send x to infinity, the answer is a. That is the meaning of horizontal asymptote. So how do you find the horizontal asymptote? You need to take the limit of your function when x goes to a. And here I don't send to negative infinity because it is mentioned that x is positive. Okay, and if this limit is a, then the question mark is what is the limit of f of x minus a? Yes?
Yeah, it should be 0.
But of course, this can be written as the limit of the first part minus the limit of the second part. But the limit of the first part is a, yes? Because here you see this limit is a. And what is this limit? This is a constant number, independent of how big or how small x is. So the limit of this one is also a. So this is just simply a minus a, and the answer becomes 0. Yes?
Could you also solve question 4109?
4109.
Yes.
We go backward. Page.
It is on page
Okay, now
170.
4109.
Yep.
Okay. 4109, page. What was the page? 117.
Yes.
Okay, so let me read the text. We have a rectangle that lies in the first quadrant with the what is that? With the corner at the origin. Yes.
Yep.
And then the other point is lying on the curve y equals to minus x squared plus 3. We want to determine the maximum area of that rectangle. Yes, something like that. Okay, so what we do, we actually try to visualize the situation. So let us say that this is the x-axis and that is the y-axis here. And I somehow try to draw the graph of that function, y equals to minus x squared plus 3. So let me consider that this is 3. So something like this. I don't want to be very precise in my drawings because that's not the point. So that's the graph of y equals to minus x squared plus 3. And then I have a rectangle which one of the corners is here and the other corner is on this blue curve. And of course, the other two corners, one of them is on the x-axis, the other one is on the y-axis. So let us try to draw one of them typically here. Yes? Something like this. And this point, so if then I want to make the area maximum. So I told you that. What is your target function here? The target function, for example, is area. You need to write a formula for the area. So let me take this one from here to here, x, and let me take this one from here to here, y. So the area is simply x times y. But the problem is that I have two variables, yes? So I need to get rid of one of the variables. But this is very simple because if this is x and this is y, if I ask you, can you tell me what are the coordinates here? You will tell me, okay, yes, the x coordinate is x, the y coordinate is y. But you see that this lies on the blue curve. So this means that y is equal to minus x squared plus 3. And then I put it here. Then my function a becomes x times minus x squared plus 3. But this is a function only of x. And of course, I have some limitation for my x, yes? It cannot be less than 0. Maximally, it can be even if it is, it cannot be 0 or cannot be 3. Okay. But then I simplify this by multiplying this in, so it becomes 3x minus x cubed. I differentiate it. I put it equal to 0. And then this becomes, x becomes plus or minus 1. Minus 1 is not acceptable, not in the range, not in the interval. Okay, so x equals to 1 is the only one here. Okay, as I told you, I calculate a of 1. What is the answer? If I replace x with 1, this becomes just 2. And then I calculate a of 0, which is 0, a of 3, which is negative. Yes? Yes. Oh, sorry, I made a mistake here because this is not 3. The maximum possible value here is the square root of 3. But it doesn't matter because, let me clean that. So this is a square root of 3. So I need to calculate a of a square root of 3. If you do that, this also becomes 0. So the maximum area, as you see, is just 2. 2 area units. So what's the answer?
Answer area units.
Okay, that's it.
Yeah.
Yeah, we can take one more question at most, and then we are done.